Well, thank you very much, Kevin. This is an exceptional opportunity. One of the great pluses of Eskay, of course, is it's in Canada. It's in British Columbia. Eskay has been around for a few years. The current management actually took charge of the company a few years ago. And in recent times, we'll say within the past 8 or 9 months, we've really built a team to take the project forward. And that's a critical step that we've made here. We've actually contracted with people out of the Colorado School of Mines, which is here near where I live in Denver. They're very smart. Thomas Monarchy, professor at the Colorado School of Mines, he specializes in volcanogenic massive sulfide deposits, which is what Eskay is. And he also has a postdoc student, John DeDecker, whose specialty is exploration geochemistry, use of geochemistry to find ore deposits. So they're really the brains behind this. Thomas did his dissertation at the Eskay Creek mine, which is immediately north of our project. So he's ideally suited to help us out here. We're in a very good position now to move things forward, especially with the financing that we recently did with Crescat. Okay, Tommy, let's scoot forward.
Yes, sir. 1 sec, sorry. So, Quentin, I wanted to ask you, why is it they call this region of British Columbia the Golden Triangle, and what makes it such a prospective area to explore?
Certainly. Look, there's certain places on Earth where there seems to be a disproportionate endowment of gold, and other metals too, in places. But in this case, the Golden Triangle is just what it sounds like. It's a triangular shaped region in northern British Columbia. You can see it's immediately adjacent to the peninsula, Pajinga sticking out of Alaska, the Panhandle. This region hosts a number of world-class deposits. You can see a few of the stars there in the map. Most of the world-class deposits within this triangle are in the southern half. You can see Eskay's property in red. We are in the southern half. Why is there so much gold here? Well, it has to do a lot with the geologic history of the terrain that underlies this area. This area was actually accreted, basically glommed onto North America through tectonic processes, subduction a few million years ago. And the rocks that were stuck onto North America were what we call archetype rocks, island archetype rocks, where you might see rocks like this would be Japan and elsewhere around the Circum-Pacific. These are a bit older. Of course, these are dating back to what we call the Mesozoic. So they're probably 150 million years old, most of them, or even a bit older. But the rocks are highly enriched in gold and silver. Actually, there seems to have been a very early event. That early event was likely on the seafloor. It produced the Eskay Creek mine, but those rocks, which formed alongside it, were also enriched. So fast forward into more modern time, subsequent processes, geologic processes, seem to have upgraded and generated some very large deposits here.
Cool.
Okay, this map shows Eskay's property in yellow. You can see we have a very large package of ground immediately south of the Eskay Creek mine. That, of course, is where Skeena is currently operating. To our east is Seabridge in blue. That includes the world-class porphyry deposits, of the Ker-Sulphurets complex. So the KSM complex is immediately to our east. The new discovery at Treaty Creek, this, of course, is Tudor and Teuton. That is part of that belt of porphyries. Yet another major discovery right in our neighborhood. And then Pretium Spruce Check mine you can see in the purple area on the eastern margin of the map. Okay, we have a number of world-class deposits surrounding us. And you can see across our property, there's a number of very important prospects. These are not deposits yet, but they're certainly exploration targets that we've already identified and in which we're going to do further work this season. So, we have very high prospectivity within the immediate neighborhood of very, very large deposits of both gold and copper. Okay, a little background about Eskay Creek Mine. This was discovered in 1989, I remember it well. I mean, everybody who was around in the industry at that time was absolutely riveted by the drill announcements that were coming out from this discovery. Nobody quite knew what it was. It was very secretive for a long time. Now we know it's a volcanogenic massive sulfide deposit, a VMS deposit. But back then, nobody knew what was going on. They just knew it was a very high-grade discovery. Eskay Creek operated for, I believe, around 20 years, continuous mining. Back in the day when it was found, there was a huge fight for the control of this asset. This was just one of those assets that everybody wanted. Why? Because of grade. If you can see the grades there at the top, 48.9 grams per ton gold. That is about as high as you can see in any active gold mine. On top of that, there was over 2 kilograms per ton of silver. Absolutely astonishing numbers. All right, so who won the battle? Well, Homestake Mining. In fact, my life was affected by this because when Homestake won the battle for the company that controlled Eskay Creek, they shifted their center of gravity out to San Francisco. They closed the Denver office here, and I shifted. I actually went over to Newcrest at that time, so it had a profound effect on me actually. But that's fine. That's a side. The wonderful thing about Eskay Creek, it generated an absolute world-class endowment of both gold. You can see 3.54 million ounces of gold, as well as 169 million ounces of silver. Okay, what does that mean? The silver, when they were mining this, the silver paid for the cost of mining. Okay, so what that means is the gold production was actually at a negative dollar value. Think about the late 1990s when Eskay was hitting its stride. It was the best performing asset in the gold mining industry when gold was touching 256 US. Okay, so once again,
can I just ask? Does that mean that they were producing gold at greater than 100% profit margin?
That is correct. Yes, when you credit the silver towards production cost, gold was, I believe, being produced at something like negative $200 per ounce. And this is an environment where gold prices were, like I said, about $256 towards the end of the 1990s. Absolutely amazing. Okay, so you want to know why Barrick took over Homestake in the year 2000? There's one reason. This deposit. Okay, this deposit's what really saved Barrick's bacon, so to speak. Okay, this was a very important acquisition. They didn't care about the Homestake mine. They shut that down immediately. But Eskay ramped it up, and they produced as much gold as they possibly could for the subsequent years. Of course, we went back into a better gold market around 2003. Barrick did very well from this deposit.
All right.
Okay. What is it? Okay, it's a VMS, volcanogenic massive sulfide deposit. These things are basically hot springs that emerge at the ocean bottom. Okay, so you have a lot of heat coming out of the earth in the submarine environment, and that heat drives the water. It actually pulls the cold ocean water in, and then through circulation, it forces it back out again at these places we call black smokers. And as the fluids rise, they have a tremendous amount of metal dissolved in them. That metal, as it cools and there's chemical changes to the fluids, it precipitates as basically a blanket of sulfide that grows up as a mound over time. You can see here a cross-section of a VMS deposit. What's interesting about these things, they're not all that big. In this case, you can see the scale up at the top. These things are often on the scale of maybe 100 or maybe a few hundred meters across. They're not all that big in footprint, but boy, the metal content in them can be fantastic. The other thing about these deposits is they almost always occur in clusters. You seldom find one VMS. On the ocean floor, when they find black smoker, these VMS deposits actually forming, almost invariably you see maybe, say a few to a few dozen of these deposits forming in, basically simultaneously. So think of Yellowstone Park, a terrestrial example. You go up to Yellowstone Park, you can drive around all day and see one hot spring after another. Same thing happens on the bottom of the ocean. You get one hot spring after another, and each one forms a deposit like this.
Quentin, what are some comparable deposits like this you see in the world today?
Yeah, look, in Canada, there's a lot of very, very famous deposits. You got Kid Creek near Timmins. It was really the single largest producing VMS deposit on Earth. It still is. It's getting near the end of its mine life. You have the Horn Mine over in Noranda. Horn Mine was a fantastic deposit, very high-grade copper, but it also had significant gold, by the way. So VMS can have a very, very large gold credit sometimes. You have deposits in Spain and Portugal, the Iberian Pyrite Belt. I was fortunate because I actually did my master's at Kid Creek, and then I ended up going over to Portugal and doing my dissertation at Neves-Corvo in southern Portugal. An absolutely wonderful high-grade copper mine. It actually had appreciable gold as well in places. These systems, these camps of VMS deposits, they're not particularly abundant on Earth, but boy, when you find a good camp, they can deliver.
Interesting. All right.
Volcanogenic massive sulfide with a black smoker. That's quite a mouthful, but it sounds pretty exciting.
Yes, it sounds like some sort of disease or something, but no. VMS deposits, that sounds much more appealing. Okay, so here we're looking at a geologic map. It's basically an anticline, which is an upfolded body of rock. The Eskay Creek deposit occupies a position at the north end of the anticline. This is a plan view. The pink blob that you see there, that's the actual footprint of the sulfide mineralization in the anticline. What's interesting about this is the limbs of the anticline, basically either side of it, extend southward from the Eskay Creek mine, and they come onto our ground at Eskay Mining. All right, so if you go to the southwest from the Eskay Creek mine, as you go down that limb, that sequence of rock, you basically go straight onto Eskay Mining's ground. And yes, indeed, we see the same styles of alteration and mineralization on our ground. But what's also interesting is on the east side of that anticline, even though it's not as well defined in this geologic map, those rocks continue and actually become more well exposed further south along that eastern limb. And we have some very interesting prospects in that sequence of rocks on Eskay Mining's ground, about, I believe, 8 or so kilometers due south of Eskay Mine. So we're in the right neighborhood. We've got most of the belt south of Eskay to explore. Okay, Gina's playing around up there at Eskay Mine, looking at developing the remaining low grade. Low grade in the case of Eskay is the 4 gram equivalent stuff. Okay, by the way, that's not necessarily low grade, but we think we have good potential to find additional Eskay-like deposits, brand new ones, on our ground to the south. Go ahead.
Quentin, I have a quick question, if you don't mind.
Sure.
What about, can you comment on the infrastructure development of the area as well?
That's a good question, and it's appropriate right here because Eskay Mine, they have a paved road clear up to the mine site. They have all the infrastructure in place right now. I mean, they did dismantle the mill, but otherwise, there's everything you need, power and road and so forth. So year-round access, no problem. In the bigger picture, what other infrastructure? Well, if you go down to the southeast, of course, Brucejack is fully developed at this point. And then the Seabridge folks are currently gearing up or permitting, all the infrastructure to bring into the Sulphurets area. So look, this area is definitely becoming more and more, accessible, and we're going to benefit from that infrastructure.
Good deal.
Okay, so this is a cross section, basically a section sliced through the ground of that previous image, and what it shows you is the rock layers that are present. The pink and purplish layers are what we call the footwall. So it's a rock below the Eskay deposit. Back when this was all on the sea floor, ages ago, these rocks were flat. They were basically, the footwall, like the rock that the fluids came up through and then issued sulfides out onto the sea floor. The sulfide bodies themselves are shown in pink, so the ore bodies are in pink. That kind of light brown or tan unit there that sandwich between the pink and the green is actually the very important unit that hosts the mineralization. It's a mudstone. It's a shale that was deposited at the time the sulfide bodies were forming. So if you think about being on the sea floor back in this time, you know, you had some kind of major volcanic event, you know, basically a lava that came out, a very extensive lava, and that's the red stuff, okay? And that probably provided the heat to drive the system. But then everything went quiet for a period, okay? So you had a lot of heat, but it circulated through the ground, brought up metals, and then deposited the sulfides along with the shales that were raining down as mud was deposited on top of that newly formed rhyolite. So that's the light brown sequence along with the red, okay? That's a critical unit. We want to find that unit. What happened next? Well, towards the end of the formation of the sulfides, you actually had another lava flow or series of lava flows come out and cap the whole sequence. And that's that green unit. Okay, the green unit is what we call basalt. And, you know, you say, well, boy, that kind of stuff things up. No, it didn't. You know what it did? It preserved things. Okay, when you actually cap the VMS shortly after it forms, and then Mother Nature can then take it and then glom it onto a continent and uplift it, you get a preserved VMS. Okay, so it's a process. You don't just form these things and instantly, you know, heave them up onto a continent. You have to preserve them and then bring them onto the continent and uplift and expose them again. So that cap rock was actually very essential. All right, but again, we're looking for that mudstone horizon. Keep going. This plan map shows you the footprint of the ore body. There's various colors here, and what they are different ore types. Okay, so ore types A and B, for example, are basically near the vent. They're near where the fluids and the black smokers were forming. You can see that, you know, there was probably eruption during this process, so things are brecciated and broken up into pieces. But those top two images on the left and the right are some of the core sulfides that are formed in that proximal environment. Very high grades, wonderful stuff. But as you go further down the mound or down the slope, and this thing was more like a trough, we'll call it, than just a nice symmetric mound. As you go down the trough, what happened is the sulfide would actually erode down the trough, and it would deposit interbedded with the black shale. So you end up with these very laminated type mineralization, which you see, and disseminated, which you see in the lower two images. Still very high grade, still made great ore, but these are the types of ore that we're looking for in this mudstone. Okay, this image talks a little bit about the VMS deposits and really their endowment of gold, where they kind of stand within, you know, gold deposits around the world. All right, so what you see here is gold on the left-hand side in grams per ton. It's a logarithmic scale. And then at the bottom, you see the tonnage, the deposit tonnage, again in logarithmic scale in millions of tons. All right, so VMS deposits can be anywhere from, say, a few tens or maybe a few 100,000 tons, all the way up to maybe a few 100 million tons. You can see the extent of polka dots on this map. Okay, the gold grades range from very, very low in some cases, all the way up to, guess what, to Eskay Creek. Eskay Creek is the single highest gold grade VMS system that we know of on Earth. Now, the diagonal lines actually tell you what the gold endowment is in each deposit. So as you can see, there's several diagonal lines down there in the lower left. 10 kilograms. That's a very small amount of gold. But by the time you get to the diagonal line near Eskay, you're talking about 100 tons of gold contained in the deposit. Eskay is slightly over that. All right, but you can see it puts it in a very special position where there's only a handful of other VMS deposits that have that kind of gold endowment, and it includes like the Horn Mine, which I talked about earlier, which is near Noranda in Canada. Look, these are a few examples, but what people should remember is this: Eskay, very high grade, in fact, the highest grade gold VMS in the world. The second thing is the tonnage of Eskay isn't all that high. In fact, it's kind of in the middle of the range. It's only a few million tons. What does that mean to me? Well, earlier I talked about the fact that these deposits occur in camps. They occur in clusters. And usually you find a whole spectrum of sizes. You might have some little ones, some medium-sized ones, and maybe one or two big ones. Where's the big one? Okay. In fact, where are all the rest of them? Okay. There's got to be more to find. All right. So I'm very excited about our prospects on Eskay Mining's ground. Most of the ground that we have is underlain by areas prospective for these Eskay style deposits.
Quinta, that's such a great chart. I'm a big fan of charts, and this is probably my favorite chart of your presentation. But in the northeast area of this chart, arguably you would think that Sandstorm's Turkey deposit would be somewhere around that. Would you like to comment a little bit on the similarities and type of opportunity that we have at Eskay Creek versus other places and so forth?
Sure, that's a good question. Look, Hod Maden, which is now in the hands of Sandstorm and their Turkish joint venture partner, is a VMS system. Okay, there's some debate geologically around it, but I'm going to stick my neck out and say it's a VMS. Extremely high grade. You can see, for instance, a drill hole that was announced, I think a few weeks ago, 3 or 4 weeks ago. I remember seeing something just phenomenal, like 100 and something meters of an ounce per ton. It's unusual to find high grade gold system or VMS systems like that, but in the case of Hod Maden, they have one. I would say it's definitely going to fall in the upper right hand corner of this image. Whether it exceeds, say, the Horn Mine, which I believe is the single largest gold endowment, I don't know, but it's right there in league.
Can you talk a little bit about the jurisdiction risk, perhaps, maybe, of exploring in Canada versus Turkey?
That's a very good question. Look, I think Canada is a fantastic place to operate. You see the market appreciate companies in Canada, even more so than most places on Earth. The jurisdictional risk is lower. I think here in the Golden Triangle, that's especially true. Look, I don't want to disparage Turkey, but I would say that there is risk there. I think that money spent is going to be better spent in Canada than it will in many other parts of the world, and that would include Turkey.
Okay,
thanks.
Move on to the next chart here. Yep.
Okay, this is geologic map. The Eskay Creek mine is a little red star at the north end of that folder, anticline. You can see how the thing continues southward. Most of that prospective belt or that trend is on Eskay Mining's ground. Okay, so we basically control the lion's share of what is prospective. The deposit formed within a volcanic trough that was present on the seafloor at the time, and we control most of it. Go ahead.
Sorry.
Okay, here you see effectively a close-up image of the geology with our land position. You can see Eskay Creek mine right at the top again. You can see its position right on the nose of that anticline. And then the anticline splits, follows, each limb follows southward onto Eskay Mining's ground. You can see we have a number of occurrences of prospects on our ground that are VMS in style that, might be potential new discoveries. Okay, so we have Sib Lulu, which is just inside our property. A lot of drilling's been done there over time, by the way, but most of that drilling through the work that Thomas Monarchy and John de Decker have done, they've recognized that most of that drilling actually targeted the footwall rocks rather than the actual mudstone sequence. So we're starting to piece that together, and now we have a much better handle on how to approach drilling in that location. Okay, so sometimes, a lot of smoke like that, people say, oh, well, there's nothing there. They've drilled the daylights out of it. Hold the phone. Okay, we think we understand it better, and we think we know where to position the drill to potentially make a discovery. Now, not only that, we have several prospects that have not been explored for years. I'm talking like decades. Okay, TV Jeff, which are to the south there, and more or less in the central part of that image, those are very high quality prospects that have only seen a handful of drill holes each, but the drill holes that are in those are fantastic. There's up to ounce plus material in both drill holes, and every indication from the work we've done, every indication geologically is we are in the mudstone sequence in that area. That's very exciting. Okay, that's now a very high priority target. Let's go further south. We have all of the smaller stars there. That's effectively the Corey block, the Corey group of prospects. Again, some of these we don't know for sure yet because we don't have enough geologic data. These things have not been explored at all, at least not systematically. But we know that they're in the right types of rocks, and quite frankly, the mudstone sequence will be preserved underneath that dark green rock in this map over a very broad area. So again, it's elephant hunting ground. We're going to do the work to find out if there's targets down there that we can test with the drill very soon. Go ahead. Okay, so a news release that came out just recently, we talked about the geophysics we're going to do. You know what? This is steep country. It's a short season out there. You got to get as much information as you can as quickly as possible. And what we've decided to do is a two-pronged approach. One is geophysical work. The second is a geochemical approach. First thing I'll talk about is the geophysical program. You can see here our property position. What I've done here is just highlighted some of the areas that have been studied by older geophysical systems. So the blue that you see kind of extending down the west side and then to the south, that was what we call a V10 survey. It was done a few years ago. It did highlight some interesting sulfide bodies, or what we believe are sulfide bodies and things like this. But the core area there from Siblulu down to TV Jeff, we need to cover that. Okay, so this year we're going to fly a similar system. It's called SkyTIM. It's an airborne system. We're going to fly over that area and basically drag a big metal loop or coil underneath the helicopter. It sends pulses of electromagnetism in the ground, and that then responds, sends a signal back up, and the machinery on the helicopter actually picks that up and gathers data that's then interpreted. And what it'll show us is things like alteration and sulfides, where that might be associated with this style of deposit. Go ahead.
Hey, Quentin, there's a question from the audience that I think it's an important question that maybe you can address. And I'll put the question here is, why did this mine did not get mined from 08 onwards?
Okay, right now we do not have a mine deposit. This is an exploration project, stage project. Okay, this is what we call elephant hunting ground. It's not a discovery yet. Eskay Creek, when they found it in 1989, it took several years. I believe it was probably 3 or 4 years of drilling to actually drill it out to a level of understanding they could develop a mine. What we have on our property are basically a large number of prospects that have already been identified, but we're also looking to generate more prospects, but that we can now drill test, hopefully make a discovery. So, this is early stage, guys. I don't want to, understate that. This is exploration stage. We are not at a stage where we have a mineable deposit. That will take discovery and then a drill out campaign to do so. But if you find one, they're wonderful deposits.
All right.
Okay, the other thing we're going to do is a ground-based geophysical approach. We're going to do IP and CSMT, or actually MT rather. Basically, fancy words. IP stands for induced polarization. It simply injects electricity in the ground, and it charges up certain minerals like sulfides. Okay, VMS, massive sulfide. All right, we're looking for that. So we want to charge up the sulfide, and then we get a response back, and we can actually see where there's bodies of sulfide buried in the ground. Great technique. Okay, MT is basically another technique that will allow us to see the layering within the strata here. And again, we're looking for that mudstone horizon. So we're very hopeful that the work we do with MT will better define exactly where that unit is, and we can position our drill holes where we need to. Now, the goal here is to develop drill targets that we can test this year. Okay, yes, we're getting to a slow start because of COVID, but we've got the money. Crescat put it in. We are now doing this work that's presented right here. And we are intending to get some drill targets lined up that we can test later this season. When is the season? Well, it usually lasts until, say, mid to late October. So we do have a window, say, from August, September, October, that we can come in here and drill. There's one other element we're doing, or one other technique we're doing, is a geochemical technique. I do BLEG work. It's basically a stream sediment style program where you collect clay fraction, the clay material out of each stream, and it allows you to see exactly where there's outcropping mineralization anywhere in your property. Anybody that follows me and the companies I help, like Irving and Lion One and so forth, they know that I routinely, religiously do BLEG surveys. we're going to do a blank survey over Eskay's ground. Why? Because I think there's more prospects than even the ones I've just talked about here. I think there's a heck of a lot more. Okay, we want to know if there's more potential on this property. We'll find it out. Okay, I have one image I thought I'd throw in here that when I saw the picture of this rock, I went, holy moly. Okay, yes, it's a butt ugly rock. I mean, this is a rock only a mother could love. Okay, but it is to a geologist a wonderful thing. You can see the brownish material is labeled as quartz siderite. What does that mean? Well, quartz is a mineral. Siderite is a mineral, an iron carbonate. Quartz and siderite often form through intense alteration of a precursor rock. In this case, I don't even know what the rock was, but the quartz and siderite have absolutely obliterated it. That tells me a very strong system. What type? I'm hoping that this might be related to VMS mineralization. It kind of looks like stockwork VMS to me, personally. Okay, the gray material that you see is a mineral called tetrahedrite. It's a silver-rich sulfur salt mineral. And why is that important? Well, in this case, this sample grades 3%, 3%, not 3 grams, not 30 grams, 3,000 grams, 3% silver. Okay, well, remember, Eskay Creek had a lot of silver, all right? What have we found? What if this sample, which was collected years ago, I don't even know who found it, okay? What if this sample is telling us that there's already a discovery on this property? Like, nobody's done significant work at that location, that occurrence, since for probably 20 years. I don't know, but there's no record, serious record. There are a number of samples within, say, a 500-meter diameter circle that were collected years ago that are grading percentage level silver. To me, that's very interesting. When you see numbers like that, that's no fluke.
Kevin, you have a question?
Well, yeah, that's one exciting, ugly silver rock there, Quentin. And remember what we talked about earlier when that Eskay Creek mine, which is not owned by Eskay Mining, that was owned by Barrick, and now it's trying to be resurrected by a different company today. But we own the surrounding property. Eskay Mining owns the surrounding property.